Okay, so after that easy question, we are going towards somewhat medium question, which will have two string and two blocks. So level of difficulty has been increased, and also instead of velocity we are having here acceleration. Now acceleration meaning you got to differentiate the length twice in order to get acceleration. So as usual, the blue box represent the correct option, and let's see methods here. So method 1, here we have already prepared x, y, z and w are the segment of the length, and here x some portion which is going to be constant, then y some portion of the string which is going to be constant, then z again this portion is constant, and then w. Now why am I telling these portions are constant? Because they are the part of circumference. Like here it is half of the circumference, here half of the circumference, here 1/4 of circumference, which is going to be here in this thing constant. Now like I said before, you got to differentiate twice, which I already did. First time differentiation, then second time differentiation, and here the length never changes, so 0, this is also going to be 0. Now we got to figure out what is d square x by dt square and d square y by dt square, and so and so, and that thing can be done in the same way. First take length x. Now x length, this point is fixed on the pulley is fixed, so this point is not going to move, this one. Now the other point is going to move because the block is moving with an acceleration a1 here. So if it is moving right hand side, this block is moving right hand side, what do you think will happen to the x? Will it decrease or increase? Well, it decreases, so minus, and it is decreasing because of a1. Now let's look at this y. Again this point on a fixed pulley, so that point is not going to move. Fixed pulley. Now other point which is right here, it is also on the pulley, but this pulley is moving. Why it is moving? Because the block is moving with a2 acceleration, so this have to move with an a2 acceleration. So in the end we are getting y is increasing because of a2 acceleration. So this is going to be plus a2. Now let's look at the z. Similar, like y, z is fixed between these 2 points, and that point is on fixed pulley. So again the upper point is not going to move, the lower point will, and it is moving with the same acceleration as the block has an a2 acceleration, so we are going to get here plus a2. And similarly for w, we are going to get the same thing, a2. It is similar to z. Again we got a 2 point here, this point is fixed because fixed pulley here, and that point is attached to the block is moving a2 acceleration, so it will increase z, that's why plus. Increase w, that's why plus. Now after that just put the values here, so you are going to get 0, and you are going to get here minus a1 plus a2 plus a2 plus a2, and this will definitely give us a1 is equals to 3a2, the answer. Now method 1 is done. As I said, time consuming, but definitely give the answer. Now method 2, oh no, we can't apply the method 2. Why? Because it is having not just one string, it is having two strings. So next thing is obviously method 3, the best method. Now the method 3 will have to adjust a little bit because we don't have here velocity. What we have is an acceleration is dv by dt, which means here we don't need to calculate power. What we do need to calculate is dp by dt, meaning rate of change of power, which is same as like power t multiplied by, instead of velocity, acceleration, and cos 0, because that is the angle between them, and dp2 by dt here is going to be total force 3t acceleration a2 and cos. What do you think the angle between them? Well, they seems to be opposite, tension upward, acceleration downward, so they are going to get 180 degree here. Now after that, total rate of change of power is 0 because power is 0 itself. So here we are getting T A and plus 3T A2 with minus 1 sign because cos 180 degree. So again you are going to get here A1 is equals to 3A2. So again solve in very less time consuming process. So this is done. Now as you can see, I have put some challenging portion. If you are willing to do it, there is extra portion here of this question that find the acceleration of B. You got to tell the answer and find the tension in the string which is connected to B, and again you have to find out the acceleration by doing what, FBD, free body diagram of both the blocks.